So today we are going to focus on solving three system equations. It's kind of the same as two systems. I can use substitution if I have a variable isolated, and then I can use elimination to make it two variable equations to solve that way. So on number one, it wants me to solve. This one has my z isolated already. So what I'm going to do is I'm going to take that and plug in for my z value right here. So I'm going to have y plus 4 times my z value, which was 2, equals 7. Then I want to go ahead and solve for y. So I have y plus 8 equals 7. I want to go ahead and subtract 8 on both sides. This gets me y equals -1. So now I know my y and z value. I can plug back into my original equation. I am going to take this z value and plug in up here, and this y value, and plug in right here. So I am going to have x minus 2, my y was -1, my plus 3 from the equation, and z was 2. This whole equation should equal 9. Then I want to go ahead and solve. I'm going to have x plus 2 plus 6 equals 9. I want to combine like terms. I get x plus 8 equals 9. I subtract 8 on both sides. I get x equals 1. Then I want to write this as a coordinate point. So I'm going to have, remember, it always goes alphabetically. So I'm going to be doing x, y, z. But that's a really ugly one. But x was 1. Then my y was -1. And my z was 2. So this is my final answer here. So for number 2, pause the video, work on it on your own, then compare with the people sitting around you, and then when you're ready, play the video and I will go ahead and solve it. So for number 2, same idea. I'm going to take this z and plug in right here. So I'm going to have y plus 3. My z value was 3. This equals 6. So I have y plus 9 equals 6. I'm going to subtract 9 on both sides. Gives me y equals -3. Now I want to go ahead and plug into my first equation. I'm going to plug that value in for z up there, and this value in for y over here. So I'm going to have 2x minus my y value was -3 plus 5 times my z value of 3, and this equals 22. So I'm going to go ahead and solve. I have 2x will, -3 is +3. 5 times 3 is 15, and this equals 22. We want to combine like terms. I have 2x plus 18 equals 22. I'm going to go ahead and subtract 18 on both sides. I get 2x equals 4. Then I want to go ahead and divide both sides by 2. So I get x equals 2. I'm going to go ahead and write my coordinate point. This is going to give me 2 for x, y is -3, and z was 3. So the next problem I have is one where I need to solve until I have isolated a variable. So this is where I'm going to combine two equations together to make it a two-variable system. I'm going to choose to put these first two equations together because I can cancel out an x. So I am going to add them together. My x's will cancel out. And I'll actually just rewrite this off to the side for now. So I'm going to use elimination to solve. I'm going to add down. So x's cancel out. -2y plus 3y gives me y. 3z plus z gives me 4z, and 9 minus 2 gives me 7. Then I want to go ahead, and I still want to cancel out x's, but now I'm going to use the last equation. I'm going to also take my middle equation and multiply by 2, so I can use elimination with it. So if I distribute that 2, that gives me negative 2x. 2 times 3y gives me 6y. 2 times z gives me 2z. And 2 times negative 2 gives me negative 4. If I add straight down, the x's cancel out. Negative 5y plus 6y gives me y. 5z plus 2z gives me 7z. And 17 minus 4 gives me 13. Then what I want to do is I want to put these two equations together and get rid of one of my variables. Since I already have y's with the same coefficient, I'm going to take this blue one and multiply by negative 1 and write it down here. So it's going to give me negative y minus 4z equals negative 7. And then I want to go ahead and combine these two equations. I get my y's canceling out. 7z minus 4z gets me 3z. 13 minus z gets me 6. Then I just want to go ahead and divide both sides by 3. So this gets me z equals 2. Now that I have my z, I can plug back into either the green function over here or the blue function right here. And the reason I'm picking one of these is because I need to plug it back into an equation with two variables so I can get another variable alone. I am going to pick the blue function just because it is smaller numbers to deal with. So I have y equals 4, and then instead of z, I'm going to replace that with 2. Plus equals 7. So 4 times 2 gets me 8. I want to subtract 8 from both sides. That gives me y equals negative 1. I am going to plug into an equation. It doesn't matter which of the 3 original I plug into, but I should be picking one of my 3 originals. I'm going to pick the middle one just because it has less coefficients. So I'm solving for x, so it's going to stay that. Plus 3, I'm going to plug in the negative 1 for y. And plus z, I'm plugging in 2. This should give me negative 2. So I want to simplify. I have negative x minus 3 plus 2 equals negative 2. Now I want to go ahead and combine like terms. So I have negative x minus 1 equals negative 2. I want to go ahead and add 1 to both sides. This gives me negative x equals negative 1. I divide both sides by negative 1. And my answer here is x equals positive 1. So my final answer should be a coordinate point. It's going to be 1, comma, negative 1, comma, 2. Because it goes x, y, z. It always goes in alphabetical order. So if for some reason I'm solving a system and the letters are like W, V, U, I would go in order of U, V, W when I write it out in my point. Okay, so again, pause the video, take a few minutes to work on number 4, compare with everyone sitting at your group, and then when you guys feel like you're ready, play the video and then watch me work through number 4. So this one is same idea. I want to go ahead and get rid of some variables. I am going to combine the first 2 equations together to cancel out that y because I see that they have the same coefficient, opposite signs. So I'm going to do x plus y plus z. I'm just rewriting for now, equals 6. And then I have 2x minus y plus z equals 3. If I combine these two together, adding down, that gives me 3x. The y's cancel out. Then I have 2z equals 9. Over here, if I add the bottom two together, I can cancel out my y's. When I'm doing elimination, again, I want to remember that I use all three equations to make the two equations. So I used the first two, and I had to use the third one. It didn't matter which of the first two I combined it with. I just had to combine it with one of them. So if I combine these together, I get 5x. My y's cancel out. My z's cancel out. And then I get 5. So this one, I actually want to go forward and solve for my x. I'm going to go ahead and divide both sides by 5. This gets me x equals 1. So I'm going to take this and plug it into my equation with two variables. So I have 3 times 1 plus 2z equals 9. Then I want to go ahead and simplify. 3 plus 2z equals 9. I subtract 3 on both sides. I get 2z equals 6. I'm going to go ahead and divide both sides by 2. This gives me z equals 3. Now I have two of my three variables. I can pick any of the three equations. I'm going to pick the first because there's no coefficients to worry about dealing with. So I know my x. This is 1. I don't know my y. I know my z. And I know this should equal 6. So I'm going to go ahead and combine my terms. 1 plus 3 gets me 4. Still have that y, and it still equals 6. Then I want to go ahead and subtract 4 on both sides. This gets me y equals 2. I have all three coordinate points, so they go in alphabetical order. X, y, z. So x was 1, y was 2, z was 3. Okay, number 5 is exactly what we were just doing. I just need to go ahead and solve it. So on this one, all of these look like I have to multiply to cancel out. I'm going to cancel out my x's. I'm going to multiply this one by -2, which will give me -2x plus 6y minus 2z equals -2, because I just distributed that -2 to all of my terms. Then the second one, I'm just going to add to it and keep the same. So when I go ahead and add, my x's cancel out. This gives me 5y minus 4z equals 0, because -2 plus 2 is 0. Then I'm still wanting to get rid of my x's. I haven't used my third equation. So I'm going to take this and multiply by -2 to cancel it out with the middle equation. I'm going to distribute, so I have -2x minus 4y minus 6z equals +2. And then I'm going to go ahead and just rewrite my second equation down below it. So I have 2x minus y minus, the 6z should have been positive. So that was a negative times a positive. Minus 2z equals 2. I want to combine those two together. -2x plus 2x cancels out. -4y minus y gives us -5y. 6z minus 2z gives us 4z. And 2 plus 2 gives us 4. I want to go ahead and put these two equations together. My y's have the same coefficient and they're already opposite signs. So I'm going to go ahead and write that one down below it so I can use elimination here. The 5y's cancel out. The 4z's cancel out. That gives me 0 equals 4. That is not a true statement. So I'm going to write no solution for my final answer. Okay. So I want you to pause the video, work on number 6, compare with your group, and then hit play when you are ready to see me work through number 6. Okay, on this one, That is a typo. I will fix this on your version. This should be just a -2. There should be no equals there. I want to go ahead and I am going to get rid of, I'll get rid of the y's. So first thing I'm going to do is I'm going to multiply this by 2y so I can cancel out with my second equation. I did forget to say this earlier. It doesn't matter which variable I cancel out at the beginning. In the end, I should get the same coordinate points no matter what. Okay, so that's my first equation when I multiply by 2. My second equation is going to stay the same, so I can cancel it out. This one, I get 5x. My y's cancel out, my z's cancel out, and I get equals 7. I'm still going to go ahead and see what happens when I try to cancel out with the bottom equation. So this one, I'm going to multiply the top equation by, I was trying to cancel out y. So I'm going to multiply by 3. That gives me 3x plus 3y minus 6z equals 9. And I'm combining with this with the bottom equation. So if I add straight down, I get 5x. The 3y's cancel out. The z's cancel out. And I have 17. So I have 5x equals, I'm going to take this blue one and multiply by -1, which is going to give me -5x equals -7. If I go to add these two, the 5x's cancel out and leave me with 0. 17 minus 7 gives me 10. Again, I have no solution here.